All right, good people, here we are. We are looking at the fundamental theorem and the accumulation model in terms of graphs. We are given the graph of f prime. This is the derivative of f. We are trying to find two things, f of 5 and f of 3. So these are two separate problems. So I'm going to maybe do f of 5 here and f of 3 over here. But we're given an initial amount. F of 0 is 4. So remember what the fundamental theorem says. To take the integral. So let's do this one first. To take the integral from 0 to 5 of f prime of x dx, that's the antiderivative of f, or the antiderivative of f prime, or the original function f, evaluated at 5 minus the same function evaluated at 0. But we already know that this is 4, so I'm going to add this over, and so we're going to get 4 plus the integral from 0 to 5 of f prime of x dx. That's going to give us f of 5. Well, in order to figure this out, I need to know the integral of f prime from 0 to 5, from 0 to 5. Well, if I'm looking for the area or the integral here, I'm really just looking for the area of a triangle, right? And so this area would be 1/2 times the base, which is 5, times the height, which is 4, and that's going to give me 10. And so f of 5 is just 4 plus 10, which is 14. I'll write it down here so we can leave a little bit of space for the next one. And that's it. That's not so bad. Okay, so then can we do something similar? And in this example, I'm going to go ahead and write it in terms of the accumulation model right away. And that says, if I'm looking for an ending point, an ending value, which is f of 3, that equals the starting value plus how much it's changed in that interval according to its rate function. Right? The integral from 0 to 3 of f prime is equal to f of 3 minus f of 0, but if I add it over, this is what I get. Well, I know f of 0 again. This time I'm looking for the integral, or I guess I'll do it in a different color so you can see it. From 0 to 3, from 0 to 3, well, that's a trapezoid. It looks like, maybe. I would think it would be a trapezoid. So then I'm going to look for the area here. Well, how do I figure out the height? How do I figure out the base? How do I do all that stuff? From 0 to 3, from 0 to 3. Well, I don't know what base 1 is. I'm going to come back to that. But I do know what base 2 is. So I have 1/2 times, I also know what the height is, 3 times base 1, I'm going to wait, plus base 2 is 4. So if I think of this as a trapezoid, this would be base 1, this would be base 2, this is the height, right? I'm seeing the trapezoid kind of on its side. Well, I know that the slope of this line, so the slope is -4 over 5, right? -4 over 5. It goes down 4 over 5. So therefore, another way to think about it is, for every one step that it goes over, it goes down -4/5. So from 4, it's going to go down 4/5, and then I get 1. And then it's going to go down another 4/5, and then I get to 2. And then it's going to go down another 4/5, and then I'm going to get to 3. So really, the y value here would be 4 minus 3 of those 4/5, which would be 12/5, which would be 8/5 if I subtract that. If I did that correctly, I think that's what that is. I guess this is what I did in my head. And then I find a common denominator. So the common denominator would be 5. That means my numerator would be 20. 20 minus, not 15, it's fifths. My bad. So then this is 8/5. What did I just find? Oh, I found the height of, or the base 1 here at this point at 3. How did I do that? Because I knew that the slope for every, according to the slope, for every one I go over, it goes down 4/5. Well, how many steps do I need? I need 3 of them. And if I subtract that from 4, that's where I'll end up, 8/5. Okay, all of that to give us that the answer is 4, let's see, plus, this is 3/2 times, this is 28/5. So that's 4 plus something tenths, 84 tenths, which is 8.4. So then that's 12.4 is my answer. That's what I'm projecting it to be. And if I look at my previous answer, remember when we shaded everything in purple, it was 4. Well, here we're not shading everything, and it's 12. I'm sorry, it was 14. Here I'm not shading everything, so it must be 12.4. Okay, that got us to that answer. And in the next video, I'll do this bottom one. I'm going to skip letter B here because I think we kind of got the idea from these two and letter A. But we'll do one more video for example 4, and then we'll be done with this accumulation model.